Okay, this is the final exam homework solution. Let's talk about the basic version first without the bonus problem. So the basic version was to have a basic wiki. This is the front page. And of course, there are other pages you can go to. And if they exist, you see the content. And if they don't exist, for example, /foo, you'd see an edit page. But I wasn't logged in, so we won't see an edit page. Let's try that again. If you try to visit an edit page when you're not logged in, it should redirect you to the login page. Okay, so I go to a page that doesn't exist, foo. Now I'm logged in. We can see I put the username in the upper right here. And we get an edit page. And if we save this page, you can see we can now go to /foo and we can see this content. Go back to our front page, all is well. And we've got logging in and logging out. All of that works. So let's take a peek at the code. Now, this actually wasn't a whole lot of code to get a pretty functional wiki. A lot of this code you've already seen before. Oh, there's my secret. Well, I guess I'll change that before I upload this. All of this code is basically from previous homeworks. So I've actually given you most of this code. Here's my normal render stir function and my make secure val for the cookie stuff and check secure val. I added this new function called gray style. And we'll come back to this for the bonus question. But this is just a little function I wrote to alternate the coloring of rows in the UI. And I don't know if there's a better way to do this or not, but this is how I did it using something that would work in Jinja, the templating language that I couldn't figure out how to do otherwise. All of these functions, this is our superclass handler that we've been using for all of our handlers. None of this stuff has changed. I've added to my render stir function. I make it so in templates I always have access to a variable called user, which is just reference self.user, and I have access to the function gray style, which is that function I just kind of pointed out. We'll come back to that. Everything else in here is actually the same. These are all basically how I left it after the end of Unit 4, really. You can see there's still some security stuff in there. I had made it so only spez could submit to the blog, and this variable isn't used in this program anymore. It's just left over. I made a new 404 page, so I can call self.notfound, and it'll actually say 404. That was something that I found kind of useful. And we've got all the salt and valid password and hashing functions. This is all, again, from really Unit 4 homework. The user code hasn't changed at all. The same stuff I demoed there. The signup handler is just about identical from Units 2 and then Unit 4 where we did the registration. So same form, same validation. You've seen all this code before. Login is all basically the same. The only real change, actually, let's go back up to signup. I'm using the refer to keep track of what URL the form should go to after you submit it. So before we render the form, I create this variable next URL, which uses the refer header, which is sent along with every request. That's the page you are on before you went to this page. So if I was on / and I clicked on login to go to /login, the refer would be /. And then, of course, I have it default to /. And that gets sent into the form as an input type hidden. And the URL to go to next after we're done signing in or logging in gets passed in the form. And you can see that down here. So this is the signup handler. In the post for that, I look for next URL in the request. And if it's there and if it's not login, because I don't want to have somebody sign up and then immediately redirect them to /login. That kind of came up during testing. If that parameter wasn't there or it's /login, we just go /. Otherwise, next URL, we wait till after we've validated everything and we redirect the user to next URL when they're done registering. So that allows somebody to click sign up on any page. And then once they sign up, we take them back to that page. So it's just an extra, kind of nice little convenience. And the login handler is almost identical to Unit 4 as well, except it has the same kind of next URL functionality. We get the refer header. I send that to my login form. I include it as an input type hidden. And then we redirect to it when the user logs in successfully. And the rest of the code is the same from the Unit 4 homework. Login is basically the same, except it also has a next URL. And it just, again, looks at the refer and redirects the user to that. Now, I should probably clean this up a little bit. We've seen this exact line, this next URL equals self.request headers next URL in 3 different places. So I'd probably pull that up into the handler, but this code is kind of a work in progress. So you're kind of seeing it here in a little bit of a raw state. This is my page class. The page model is pretty simple. It just has content, a created time, and a last modified time. And I also wanted to have the notion of an author, of what user created a particular page. But it actually wasn't relevant to the demo, so I didn't bother finishing the implementation, but it would have looked something like this. So you can see, again, this code is kind of in a working state. And actually what is online right now might differ from what I'm explaining here because I've had a few more weeks to work on it to make it a little prettier. So you may see this feature implemented when I release the code. or you may see this line be gone altogether. Now, I've added a couple class methods. Some of you actually asked about this in some of the previous homeworks. What static method and class method do? Static method basically means you don't have to pass in self to a function, which means this method here is just static. It doesn't run on an instance of the class. It's just basically a way of organizing code a little bit better. This function parent key is only going to be called in the context of a page. So I just basically say this parent key function belongs to the page, and that's kind of how we're going to reference it in our code. But it doesn't actually take an instance of the class itself or the class itself like class. It operates kind of independent. And what this function is actually doing is to make the history function work. There's a little trickery there. And I'll kind of come back and explain this a little bit more detail when I explain the solution to the bonus problem. And then I added two class methods. One is by path for looking up a page by URL, which is kind of the default way of looking something up. And all this does is this runs an App Engine query or data store query. This is a class method. And what class method does is says, instead of running by path on an instance of page, run it on page itself, just the definition. So you can say page with a capital P dot by path, give it a path, and it will return a query object. And basically what this is saying, it says, get me all the pages for this URL sorted by creation time. And that's kind of how I did versioning. I'll come back to that in more detail again when I talk about the bonus problem. And of course, looking up page by ID, this is strictly for the bonus problem, looking up older versions of a page. So if you want to look it up by ID in addition to the path, that's what this function is for. No slash was a special handler I had for getting rid of extra slashes in the URL. It was kind of a work in progress, so it wasn't working in this demo, so I'm going to have to come back and clean that up. Just ignore that for now. Here's the edit page handler. Edit page is the handler for actually editing one of the wiki pages. First thing we do is we check to see if the user is logged in. If the user is not logged in, we redirect to /login. That's important because you don't want non-logged in users to be editing your pages. They should be registered so you know who's doing what. This code here is for the extra of the bonus problem. If you didn't do the bonus problem, all you need to really do is look up a page. And so this is that by path function that I just explained on the page object. We give it the path, and then we get the page object. Now you can structure this however you like. And what that by path function returns is a query. And on a query in data store, you can either call get to get the first element of the query, or you can call fetch to get multiple ones. And I'm calling get because I only want the first one. And then we render edit.html with that page, and we include that path so I can render some of the links that appear in the navigation section. Here's the definition of post for the edit page. Again, we check to see if the user exists. Now you may say, well, if the user didn't exist, how do they view the edit page? Well, they could have the browser, they could have a couple tabs open or multiple browser windows open. And if they log out in one and then submit a form in the other, that could cause some problems. So what we do is if the user's not logged in, we just return an error 400, which is basically a bad request, and return. Now, I didn't do anything user-friendly here because that shouldn't happen, so it just kind of silently fails. Then what we do is we look for the actual content in the request, and then we look up an old version of the page, and then we have this little thing here. Basically, if there wasn't an old version of the page, basically you're creating a new page, and there wasn't any content, just return. I'll probably expand this to have an error message, but we left that a little undefined in the problem, so I hadn't implemented it right away, and so right now we're just kind of ignoring that. And otherwise, if we either don't have a page and have content, which is what kind of this clause implies, or we do have a page and the content is changed, I make a new instance of page. Now, depending on whether or not you did the bonus problem, you could have edited an old version of the page. In mine, I want to keep this version history, so I keep a new version. I create a new page for every change, and then we store that in the database. And then we redirect to the just the path without the _edit, so you can actually view the content. I'll skip the history page handler, but it's actually pretty simple. We'll come back to that in a second. Wiki page is the handler for actually viewing any page on the wiki. So it takes a path argument just like the edit page does. Notice it's only a get, there's no post here. This code here is identical to the edit page, and so again, I'll probably clean this up. This basically decides, whether you are looking at an old version of the page with a version number or the most recent version of the page. And if you didn't do the bonus problem, all you need is something like this. This says, just look up the most recent version of the page. If it exists, we render page.html with that page. And I also include the path so I can render those links. If it doesn't exist, I redirect the /_edit plus the path. So how did I do all the URL handling? It's actually pretty simple. What I did is I created a regular expression to match what I think is a valid URL. So basically it has to start with /, and then it contains one or more of the following characters: little a through little z, big A through big Z, 0 through 9, _, and dash, followed by an optional slash, and then as many of those clauses as you want. So that basically means valid slash, or slash is valid, and then any number of these clauses is valid after that. And then our URL handlers look something like this. So slash signup goes to signup handler, login, login, log out. These are all handlers you've seen from Unit 4. This was my no slash thing that is currently not working, so I commented it out. Now, remember these URLs get matched in order. So you want to make sure that like this URL, this handler here, or this regular expression for rendering a wiki page would actually also capture the history URL and the edit URL. So we need to put those history URLs in the history URL and the edit URL first, so they get matched first. So what this one says here is it says if the URL is of the form /_history plus this regular expression, basically /_history / anything, match the history page. If the URL is /_edit, basically anything, go to the edit page. And if it's anything else, go to the wiki page. And that's how we go to one of those three handlers. So if we take a look at the app again in the browser, now that we kind of have seen the code, some things will make a little bit more sense. So when you just go to slash, we go through a URL matcher and we say, okay, it doesn't match login, sign up, or log out. It doesn't start with _history or _edit, so we match the other thing. And our path now becomes slash, and then we look up, using our database query, the page for slash, and we get this page. Now if I were to go to /new page, we do the same thing. We use this as the key into our database, and we look up the most recent version of new page. And here it is. Now let's talk about editing a page. I'm not logged in, so I don't have my edit link. Let's go ahead and log in so we can see the edit link. Okay, so here I am on new page. Now I'm logged in as Spez, and I have my edit link. And I'll show you those templates in a moment. When I click on edit, you can actually see it basically links to _edit /new page. So it's basically inserts an _edit here. And remember, that goes through our edit handler instead of the normal wiki handler. So when I visit this link, the edit handler draws the different form, which gives us this whole form. And I can, I'll just click save here. It didn't change the content, so we didn't create a new version. So that's how edit works. Now, of course, we can go to any URL. And if it matches the wiki handler first, let's look at the wiki handler again. This wiki handler first, but remember, if the page, if it doesn't exist, we redirect to /edit plus the path. The path is passed in by this regular expression. So if we go back to our browser, what's going to happen is we're going to redirect to _edit this string. And there we go. That works. Now, what if I go something like this? Actually, let's take a page that already exists. Will this work? Yes. We get the edit page on this URL. Now remember, our regular expression just basically matches any number of things. So we can actually create a whole complicated URL structure. And that's pretty cool. So if I were to say, here's the subpage and submit this, it works. And if I were to go back to new page, that works as well. So pretty cool.